Hi everyone, moving on to Unit 3, Derivatives, Subsection 1, Derivatives and Limits. So, Part 1, Connecting Derivatives to Limits. Okay, so recall from last unit, it was hard for us to figure out the slope of the tangent line because, well, our slope formula requires 2 points, and to have a tangent line, you only have 1 point. And remember, we got around that by drawing a whole bunch of secant lines, and we made the second point get closer and closer to the tangent point. And what we found out is we were finding the limit as x approached the tangent point. Okay, we had this little picture, and eventually, and I'll write in red, okay, maybe that red, okay, what ended up happening is we got that second point, like we started there, went there and there, and got closer and closer, and we found the limit as x approached a, and we got our tangent line. Woohoo! Now, remember we went through tons of examples, okay? We used two different formulas to find this, and we started out with this one, okay? The limit is h approach 0 of f of a plus h minus f of a, and we called that the first principle of calculus. And okay, great, it was still finding limits, but that's all right. Okay, now what we didn't tell you last unit is really that's the derivative. The derivative is simply the general equation derived or made from the original function to represent the slope of a tangent line at any point on the curve. So it's using this little formula here. Okay, remember this is the formula that gives us the equation for the slope. Remember, because the other equation we had to figure out the slope every single time, and that was a lot of work. So this particular equation gives us a slope equation, or a formula that gives us a general slope. Okay, and now we're calling that a derivative. Okay, there are several different notations, and this did not come across all that well on the PDF. Sorry about that. So I'll write it again for us. Okay, so if we have the original function of f of x, okay, so we call this f prime. So the derivative is f prime of x, or sometimes just f prime. Okay, so the prime is kind of like a little quotation mark, a single, like almost like apostrophe, I guess. Okay, so the thing is, if our original function is y, then we can have y prime. Okay, and then this Leibniz notation. Okay, so this is one of the founders of calculus. He always used this dy dx. So that is the derivative of the function y with x as a variable. So let's play with that for a minute. If we had a function like this, let's say y equals a squared plus, I don't know, a minus 5, something like that. Okay, so if we wanted to take the derivative of that, it could be y prime. Or if we used this Leibniz notation, it would be the derivative of y, but this time a is the variable, so that would be like dy dA. Okay, and that comes up a lot because we're not confined to using x's and y's, right? So really, I guess if we wanted this guy, so let's make this one a different letter, so like b equals a squared plus a, so that would be dB dA. Okay, not a big deal, it's just they all mean the derivative. All right, so now that we know we're calling this the slope formula a derivative, we can change the wording for our questions. So for instance, example 1, if f of x equals that, find f prime of x. So really, like I wrote down here, all it's asking us to do is find the slope of the tangent line, or rather the equation for the slope of the tangent line. Okay, so our only skill to do this right now is the slope is going to be the limit as h approaches 0, okay, of f of x plus h minus f of x all over h. Okay, so this is that formula we use. It's all good. Okay, so let's just carry on. So limit as h approaches 0. Okay, so this is going to be 2x plus h squared plus 4 x plus h minus 1, all minus, okay, so the original function, so 2x squared plus 4x minus 1, okay, all over h. Okay, so now we have some expanding to do. H approaches 0. Remember, we have to write the limit as h approaches 0 every single time. Okay, so then we're going to expand this out, so that's going to be x squared, but I'm going to times it by 2 just all in one step. So that's going to be 2x squared. Okay, and so the middle term is going to be 2xh, okay, and then times 2, so that's going to be plus 4xh. And then it's going to be, so h squared, okay, and then of course times 2, so plus 2h squared. Okay, plus, guys, look, if you need to expand that out with more steps, go ahead, but if you don't, then don't. Okay, so then this guy is 4x plus 4h minus 1. Okay, and then that negative, of course, distributes here, so then negative 2x squared minus 4x plus 1. Okay, and all divided by h. Now remember, we're trying to cancel off the 0 over 0 part, so really everything on the top without an h should cancel. And that's kind of a little check and balance to make sure we're doing it right. So if you have a look at this, the 2x squared minus 2x squared, that cancels. The plus 4x, the minus 4x cancels, and the minus 1 and the plus 1 cancels. So really, we're left with the limit, as h approaches 0, 4xh plus 2h squared. Okay, cancel, plus 4h. Okay, those are all gone, all divided by h. So now, everything we have up top has an h, so we can factor that out. And you get 4x plus 2h plus 4 divided by h. So, oh, look, the h's cancel. So there goes the 0 over 0 part, like we were hoping for. So this is now the limit as h approaches 0 of 4x plus 2h plus 4. So, of course, now that the 0 over 0 is gone, we just substitute the h in. So 2 times 0 is this part, so that cancels off to be 0. So our answer is 4x plus 4. Okay, so remember that is now the slope of our tangent line at any point on this curve. Okay, so let you guys have a quick look at that. So that's that one. Okay, so number 2. So same kind of thing. So if y equals square root of x plus 2, we're going to find the derivative of y with respect to x, or y prime. All right, so we have a good look at this. All right, so that's the same kind of thing. So the slope equals the limit as h approaches 0 of square root of x plus h plus 2 minus x plus 2 all over h. Okay, so that's all great. Remember, if we sub that in, we get 0 over 0, very bad. Okay, so we need to try and fix this. The idea, remember, with square roots is to use a conjugate pair. So, okay, so x plus h plus 2 plus x plus 2. Whatever you do to the bottom, do to the top. X plus h plus 2 plus root x plus 2. Okay, so remember when we multiply a conjugate pair, it's a FOIL type action, but remember the O and the I cancel, so it's kind of like a FLE. I like saying that, FLE. Awesome. All right, so we get, so root x plus h plus 2, so times x plus h plus 2, so that just works out to x plus h plus 2 minus, okay, and then right, the O and the I cancel, so it's just the L, so that's these guys. So negative root x plus 2 times positive root x plus 2 is just minus x plus 2. Now please notice I put that in brackets because that minus sign belongs to both chunks. Okay, all divided by h. Oh, broke the rule. All right, that is the limit. We still have to write that. limit as h approaches 0. Okay, and then of course we still have the bottom part, so h and then x plus h plus 2 plus root x plus 2. Okay, we're not going to bother simplifying that out at all, because watch what happens. Okay, so the x and the minus x, they're going to cancel, and the plus 2, and then this is going to be a minus 2, so that's going to cancel as well. Okay, so all we're left with on top is an h. Okay, so that's going to be the limit as h approaches 0 of h over h root x plus h plus 2 plus x plus 2. Okay, so we have that. Now, of course, the h over h cancels. So the limit as h approaches 0 of 1 over root x plus h plus 2 plus x plus 2. Okay, so now the 0 over 0 is gone, so now I just substitute and I put the 0 in here. So this is going to be x plus 0 plus 2, which is just x plus 2. So this is really 1 over square root x plus 2 plus square root x plus 2. Well, hey, there's two exactly the same things adding, so that's going to be 1 over 2 x plus, or root x plus 2. Okay, right? If there's two of these things, they're like terms, so we combine them, and there's now two of them. Okay, and there we go. There is our slope of the tangent line, 1/2, here, 1 over 2 root x plus 2. Okay, wow, that was big. Okay, and then the last one. Okay, now this one is going to get a little mean, but, that's okay. All right, so dy dx, that just means find the derivative. So again, right now our only tool to do this is the limit. So limit as h approaches 0. Okay, so this is going to be x plus h plus 1 over 3x plus h minus 2. Okay, so that's, right, you add the h to every part that has an x. And then we subtract the original function, x plus 1, for 3x minus 2. It's not exactly great writing, sorry guys. Okay, and then all divided by h. Okay, so not so bad. All right, well, the real question is, how do you simplify this? How do we add or subtract fractions? Well, remember, we need a common denominator. So the common denominator is going to be just the two denominators multiplied. Okay, not a big deal, because we're just multiplying the two denominators. Okay, I'll just show you guys here. Okay, so this guy here is going to be 3x plus h minus 2. We'll use square brackets. Okay, times 3x minus 2. Oh, square brackets. Okay, so that is the common denominator here, and we just multiply those two pieces. Okay, so remember so we multiply the bottoms, and then we're really just cross-multiplying up this way. So we're going to get x plus h plus 1 times 3x minus 2 minus, okay, and then the x plus 1 is there first, and he's going to multiply this bottom part, so 3x plus h minus 2. Okay, a little crazy, but that's okay. We're gonna deal with this. It's not a problem. Okay, sorry, and then of course all divided by h. Okay, yeah, this one's gonna get a little bit big, but that's the way this stuff works. The good news is we won't have to do this ever again after your formative assessment. Well, maybe once on your exam for this, but that's okay. Let's not get ahead of ourselves. All right, so this is going to rainbow like that. Okay, so obviously rainbow distributive law. Okay, so we have 3x squared. Okay, cool. And then x times minus 2 is minus 2x. Okay, then we're going to have the h distributing in, so plus 3xh. Okay, minus 2h, and then plus 3x minus 2. Awesome. Okay, good, good. Now, if we look at this part, let's distribute that in. So that's going to be 3x plus 3h. 3x plus 3h. That'll just make the distributive law of the FOIL part a little bit easier. Okay, so this x is going to rainbow to that, and to the minus 2. And remember, it's a negative. Okay, so we're going to have negative x times 3x. So that's going to be negative 3x squared. Okay, negative x times negative x times 3h is minus 3xh. Okay, and negative x times minus 2 is plus 2x. Okay, awesome. Then the plus 1 is going to distribute to all three parts as well. So 1. So, and that's going to be a negative as well. So negative times positive 1 is negative 1 times 3x. So that's going to be negative 3x. Okay, and we're going to get negative times 3h. So that's going to be minus 3h. Okay, wow, this is big, hey? So then negative 1 times negative 2 is plus 2. Okay, wow, that's big. Okay, and then of course 3x plus h minus 2 times 3x minus 2. Okay, all of course divided by h. Wow. Now, that's okay. It's big, but it's not undoable. So let's have a look. Because remember, if we do this right, everything without an 8 should cancel. So, you know, I'm going to draw in blue here again, just so you can see it a little bit better. Okay, so look, there's a 3x squared here and a minus 3x. Well, that's a good start. Okay, we have a minus 2x. Oh, look over here, a plus 2x. Okay, so those cancel. Awesome. Let's see. Oh, look, there's a plus 3x here and a minus 3x. Nice. Very, very good. Okay, we have a minus 2 and a plus 2. Good. Now look, 3xh, okay, minus 2h, those are little check marks, minus 3xh, and minus 3h. So everything we have left has an h. That is a good thing. All right, so let's write down what we've got left. So we have 3xh minus 2h minus 3xh minus 3h. Hey, are you guys seeing this? Look at that. 3xh minus 3x. So those cancel too. That's even better. Okay, all divided by 3x plus h minus 2. 3x minus 2, all divided by h. All right, so that's nice. And guys, what is minus 2h minus 3h? Well, last time I checked, those are like terms. So that's going to be minus 5h over this whole weird thing. So 3x plus h minus 2 times 3x minus 2. Okay, great, all over h. Now, remember we talked about this a long time ago when we divide complex fractions like this. Line 1 and line 3 are allowed to cancel. Okay, so there goes the x over the 0 over 0 part. So look, this is going to be negative 5 all over 3x plus h minus 2 times 3x minus 2. So that's pretty cool. And now that the 0 over 0 is gone, I can put the 0 in. So x plus 0, well, that's just x. So look, this part here is just going to be x. So it's going to be 3x minus 2. So it's negative 5 over 3x minus 2 times 3x minus 2. Okay, so all the h's are gone. And oh, one last thing. Look, those are both the same. So it's negative 5 over 3x minus 2 squared. Boom. Wow, that was a lot of work. But as you can see, it did simplify out to one nice little slope formula. Okay, so I'll let you guys absorb that. You might have to watch this one again because that was big. But trust me, this is going to get a lot easier because I'm going to show you a shortcut very soon. Okay, so that's it for part 1.